Okay, this is a review of perfect competition. Okay, with perfect competition, what we learned is that you always draw two graphs. One graph is the industry. At the industry level, you have the demand, you have the supply. That's where the price is determined. Then you have each perfectly competitive firm takes that price as given. That price is the marginal revenue the firm faces, okay, because they can sell as much as they want as long as they set the price equal to the market price. And for every additional unit they sell, the additional revenue is the price that they charge, okay? And that is effectively the demand that they face for their product. Because from their point of view, they can sell as much as they like as long as they match the price of the industry. And that's because they are so small relative to the whole market. Okay, so that's the demand they face. They know their marginal cost of production. And the profit maximizing condition is always marginal revenue equals marginal cost. That's always the profit maximizing condition. So this is marginal revenue, this is marginal cost. This is how the firm figures out what quantity to produce. Okay? That's basically, so they take the price as given and they choose the quantity where price equals to marginal cost. Okay? So again, the profit maximizing condition is marginal revenue equals marginal cost. In the case of a perfect competitor, price is the same as marginal revenue. So in the case of the perfect competitor, the profit maximizing condition becomes price equals to marginal cost. Okay? How do we know if the firm is making money? Well, you compare price to average cost. If the price is greater than average cost, that means that profits are positive. If the price is equal to average cost, that means profits are zero. That's break even. If the price is less than average cost, that means the profit is negative. And again, we're talking about economic profit, which is the profit after you've taken into account your accounting profit and your opportunity costs, your implicit costs. Okay? All right, so if I draw the average cost curve like this, so in that case, at the quantity I'm producing, here's the price, here's average cost, I am making positive profit in this case. This much positive profit times this many units, so my total profit is actually this whole area. Okay, let's say that I draw the average cost curve like this. So then at the quantity, here's the price, here's the cost, I would be losing money. Okay, this is the total amount that I would be losing. Okay. If I were to draw the average cost curve like this, so at the quantity, price is equal to average cost, and that means I would be breaking even. Okay? We said, let's say that you are making money. So if you're making money, good for you, right? My average cost curve is down here, good for you. What if I am breaking even? Again, good for you. What if I am losing money? So again, price is less than average cost. Should I shut down this business now, right away, or not? And the answer we said was it depends where the average variable cost is. The average variable cost is always less than average cost, and the difference between the two, the difference between average cost and average variable cost, is the average fixed cost, which we know gets smaller and smaller, right? Remember, total cost is equal to fixed cost plus variable cost. If I divide everything by quantity, I get average cost is equal to average fixed cost plus average variable cost. That means average cost minus average variable cost is average fixed cost. and we know average fixed cost gets smaller and smaller. Okay? That's average fixed cost. And so that's why the difference between the average cost curve and the average variable cost curve is something that is getting smaller and smaller. That's what you see. The distance between them is getting smaller and smaller. Okay, having said that, as long as the price at the quantity you're producing, if you're losing money, meaning price is less than average cost, as long as price is greater than average variable cost, you stay in business in the short run. In the long run, once your fixed cost goes away, you shut down. Once, let's say I draw it differently. Suppose that I say, hold on a sec, I have to rewind. Seriously? Come on. Okay, fine, we'll do it this way. Nope. Oh, okay, fine. Okay, so let's say that here's demand, here is supply. I take the price, plug the price into the firm. This is the marginal revenue. Here's the marginal cost. Suppose that my average cost looks like this. So I see that I'm losing money, okay? If my average variable cost is like that, that means here is even less than average variable cost. This is, I should be shutting down. So actually, this is already, I've shut down. So in other words, all these points on the marginal cost curve where the price is less than average cost, they don't exist. Okay, I should be erasing these. They don't exist. I would not be opening the business. The business would be shutting down. Okay, which means that only those points on the marginal cost curve above average variable cost is where I am producing. Okay? All right, so now we talked about the shutdown condition, right? And we've just figured out that in the short run, okay, the marginal cost curve, all those points on the marginal cost curve above the average variable cost, those are the supply curve of the firm. Okay, so let's say the average variable cost curve is down here, which means these are all parts of the supply curve of the firm in the short run. Okay, all right, and what we're going to say is suppose that the average cost curve is over here. So in this case, you're losing money, okay? But you're staying in business in the short run because price is greater than average variable cost. Eventually, what's going to happen in the long run? In the long run, you're going to exit, right? But you're not the only one in this industry. There are other companies like you that are losing money, and their fixed cost comes due before you. So what will happen is, as they start shutting down, the supply curve will shift to the left. There are fewer of those guys out. When the supply curve shifts to the left, the price actually increases. And the price increases, I'm able to produce a higher quantity, but it looks like I'm still going to shut down in the long run. Okay? What if I'm very, very lucky and other people continue to shut down, and now the price is just equal to here, just equal to my average cost? Now I can stay in business because I'm breaking even. Okay? What if people continue to shut down because they have very high costs, okay, and the price increases, and now the price is here, and I'm actually making money. Very nice. When I'm making money, other people are going to hear what's going to happen. They're going to come into the industry until the only thing that's going to survive in the long run, because of free entry and exit, the only thing that's going to survive in the long run, where nobody wants to come in and nobody wants to exit, is a situation where I am just breaking even. Everybody is just breaking even. If everybody is just breaking even, that's a long run equilibrium because there's no reason for anybody to exit. There's no reason for anybody to come in. Okay? And so that's why we said, whereas in the short run, price equals marginal cost, this is the supply curve of the firm. In the long run, price equals average cost is the long run supply curve. Okay? So how do we interpret that? The way we interpret that is we say, well, we know in the long run, price has to equal to average cost. So I have to see where my long run average cost curve is. And if you remember when we spoke about long run average costs, right, we said that, the long run average cost curve was like this. It was the lower envelope of all the short run average cost curves, right? For some industries, their long run average cost curve is always falling, okay? These are increasing returns to scale industries. For some industries, the long run average cost is always rising with quantity. These are decreasing returns to scale industries. For some industries, the long run average cost curve is flat, so that would be constant returns to scale industries. Okay? So let's talk about a situation where you have a constant returns to scale industry. So this is an industry where its long run average cost curve is perfectly flat. Okay? So let's say that you have your equilibrium and the price is equal to average cost, so that means you are at a long run equilibrium, and there you go. Very nice. Now, something changes. This product becomes very popular. The demand for the product shifts to the right. So now, what happens? Price goes up. When price goes up, now this is how much you're producing and you're making money. If you're making money, other people hear that you're making money, they come in. And how many of them are going to come in? They're going to keep coming in until the new supply is over here and the price is back to price equals to average cost. Okay? So you're going to come right back to here. Okay? Let's do another example with an increasing cost industry. Okay? The increasing cost industry, the long run average cost curve is trending upwards. Okay? As you produce more and more quantity, average cost in the long run is rising. Okay? And for each firm in this industry, currently this is the price, right? Take the price as given, okay? And we know it's in long run, so here's my marginal cost, and wait, wrong button. Let's make it nice. Here's my average cost. Okay, so I'm breaking even. I'm in long run equilibrium. Okay, let's say now something changes. The product becomes very popular. Demand shifted to the right. Price goes up. If price goes up, now you're going to be producing a larger quantity, and now you're making money. If you're making money, you're making a profit. Other people are going to hear you're making a profit. They're going to enter this industry. How many are going to enter? Until you reach a new equilibrium where price is equal to average cost again, meaning where you're breaking even again. Okay, so wait a minute. That would be where, let's put it in a different color, right? So this would be this price. Okay, but weird. Here, that's strange, right? Because here it shows you're still making money. Well, it must be that when you move to this new equilibrium, you shift to a higher average cost curve. Okay, so that you're breaking even at the higher average cost curve. Remember, the long run average cost curve, right, was made up of these short run average cost curves. So it must be that when you move to this new point, it has a higher short run average cost curve associated with it, which is here in green. Okay, so that at the new price, you're breaking even again, but at higher costs. Okay? Okay. Let's now try to go over the quiz associated with this. Okay? All right. If a perfectly competitive firm is producing where marginal cost is rising and greater than marginal revenue, what should it do to maximize profit? So we know that if you're maximizing profit, marginal revenue has to be equal to marginal cost. Okay? If marginal revenue is greater than, or rather, if marginal cost is greater than marginal revenue, that means that you're producing too much, right? Remember, right? Marginal revenue is constant in perfect competition, and marginal cost is rising. You want to be over here where they're equal. If you're producing a quantity where marginal cost is greater than marginal revenue, you want to reduce your quantity. Okay? So the answer here would be to maximize profit, it should decrease the level of production. Okay, which of the following is true about the marginal revenue of a firm in a perfectly competitive industry? The marginal revenue is constant, right? Because price is equal to marginal revenue equals to marginal, which is, so the marginal revenue is equal to the price and it does not change. It's constant. Suppose that a firm is producing the profit maximizing output under conditions of diminishing returns. Okay? Its output price is $25 and its marginal cost of production is $25. So price is equal to marginal cost. Very nice. That's telling me it's profit maximizing. Based on this information, it can be concluded that this firm must be a perfectly competitive firm. There we go, right? So when price is equal to marginal cost, that's the profit maximizing condition for perfect competition. This must be a perfectly competitive firm. Let's look at whether the other ones are correct. Can it be a single price monopoly? We're going to talk about monopoly later, but monopoly price is always greater than marginal revenue. And when marginal revenue equals marginal cost, that means price is greater than marginal cost. So this is not a monopoly. Should it decrease its output to maximize profit? No, right? Because it's already maximizing. Price is equal to marginal cost. Okay. Should it exit the industry? No. Well, we can't tell, right? Because we can only tell that if we know about its costs, about average costs and average variable costs. Increase its output, you cannot tell that. So really, it's a competitive firm. And we're told, right, it's producing the profit maximizing output. If it's the profit maximizing output and price is equal to marginal cost, it must be a perfectly competitive firm. Assume that for a perfectly competitive firm, marginal cost is equal to average variable cost at $10, marginal cost is equal to average cost at $15, and marginal revenue equals marginal cost at $12. Okay, let's draw this out. Okay, hold on. hold on a second. Okay, so we're told, so we know that here's marginal cost, here's average cost or average total cost, and here's average variable cost. So we're told that marginal cost equals to average variable cost at 10. Marginal cost equals to average total cost at 15. Marginal revenue equals to marginal cost. Marginal revenue is price at 12. So in other words, we have a situation where the price is equal to 12. Okay, so this is a situation where the firm is producing this quantity, where marginal revenue equals marginal cost. It is losing money, but it is not shutting down. In the short run, it's going to stay in business. Okay, so let's see. So this firm should operate in the short run, even though it will sustain a loss. So even though it's losing money, it's still going to be operating in the short run because it's going to lose less money than if it shuts down immediately. Okay. JC Pizzeria has a year remaining on an unbreakable lease on its building, requiring a payment of $20,000 a year. That's its fixed cost. If JC operates over the next year, it estimates that its revenues will be $200,000 and that its expenses, excluding the lease, without the lease, the expenses will be $190,000. Okay? So what we have is, forgetting about the lease, it will make $200,000. The costs are $190,000, so it's actually the revenue is greater than the variable costs by $10,000. Okay, so by operating, it makes a $10,000 profit, but because it has a fixed cost of $20,000, it's losing money. So this is a situation where it should stay open in the short run and shut down in the long run. Okay, JC should operate since it will earn a profit. No, it's not earning a profit, it's losing money, but JC should operate since its loss is less than its fixed cost, right? The amount it loses by operating is $10,000, which is less than its fixed cost. So that's the answer. Okay, this is the answer. Which of the following indicates that a perfectly competitive firm is in long-run equilibrium? In long-run equilibrium, price equals marginal cost equals average cost. Okay? Assume that olive oil is produced in a constant cost, perfectly competitive industry. That means the long-run average cost curve is flat, which is currently in long-run equilibrium. If the current price of olive oil is $5 a quart and the demand for olive oil increases, then the price of olive oil would change in which of the following ways in the short run and in the long run. So this is the situation we have. Okay, the situation we have is you are in long-run equilibrium. Price is $5, right? And you are a constant cost industry, and you're in, so long-run average cost. This is a flat line at $5, okay? And takes the price. Here's the marginal cost, and you're breaking even at $5, okay? So if demand for your product increases now, in the short run, price will rise. Hold on. In the short run, price will rise. When the price rises, now you'll make a profit. When other people hear you're making a profit, they're going to enter the industry, which is going to drive the price back down to $5. So in other words, the price will go up and then it will go down. Okay? So in the short run, price will be more than $5. In the long run, it's going to be $5. So this is the answer. Short run price more than $5, long run price is $5. For a perfectly competitive increasing cost industry, okay, so this is where the long run average cost curve is trending upwards. An increase in the industry's demand will lead to which of the following in the long run? So here it's a situation where, okay, we said here is the industry. It's an increasing cost industry. So that means the long run average cost curve is trending upwards. Okay. So in the long run, okay, what happens if there is increasing demand? Increasing demand, price will go up, then other companies enter the industry. You end up at a permanently higher price with a permanently higher average cost curve. Right? Because you remember, here's the increasing cost. If you're ending up from here to here, the average cost curve associated with it will be permanently higher. Okay? An upward shift in each firm's long-run average cost curve. Not the long-run average cost curve, the short-run average cost curve. A decrease in the price of an input? No. A decrease in total producer service? No. An increase in each firm's profit? No. A decrease in total... Wait a minute. For a perfectly competitive, increasing cost industry, an increase in the industry's demand will lead to which of the following in the long run? It must be an upward shift in each firm's long-run average cost curve. It's actually a mistake. It should be the short-run average cost curve. Okay? None of these is correct, right? Because the profits have to, in the long run, be zero. Okay? In fact, industry sales must be increasing, right? Because you see total quantity sold is actually increasing. We can't say anything about producer surplus. In fact, we know profits are going to be zero. So the producer surplus will be zero anyway. A decrease in the price of an input and a decrease, no, it's not true. So actually the only answer is this one. Okay. Which of the following segments of the marginal cost curve lies entirely on the firm's short-run supply curve? So we know the firm's short-run supply curve is the marginal cost curve for all points above, where price is above average variable cost. So TUV are on the supply curve. S is not, because it's below average variable cost. So TUV. The short-run supply curve of a firm in a perfectly competitive industry is its marginal cost curve above the minimum point. No, it's marginal cost curve above the minimum point of its average variable cost curve. Okay, remember that here's average variable cost, here's average total cost. Marginal cost is crossing each one at its minimum, okay? And so the points on the supply curve of the firm in the short run are all those points on the marginal cost curve above the minimum point of average variable cost. The graph above shows the cost curves for a competitive firm that produces 20 units of output. Okay, so we have, here's the 20 units of output. For that amount, right, you see marginal cost is above average cost, so it's making money. Okay, what are the total cost and total fixed cost of producing 20 units? Well, at 20 units, okay, we know the average cost is $6. So what's the total cost? Remember, average cost is total cost divided by quantity. So if we want to get back the total cost, we want to multiply the 6 by 20, okay, which is $120 of total cost. And fixed cost, well, here we have average variable cost. If the difference between average cost and average variable cost is average fixed cost, the average fixed cost is $1. The total fixed cost is $1 times 20, which is 20. So the fixed cost is 20, the total cost is 120. Okay? All right, so that is it. I hope you found this helpful.